This is my Precalculus course. Today we're going to prepare for part 1 of the final exam. This course is too big to give you an exam that is only one part, so we're going to break this into 2 parts, and this will allow you to review the first half of the course separately. So as usual, we're going to do some practice exams. I've said it before, I'll say it again, it doesn't matter how many times you tell students to study for an exam, they're not going to do it. A lot of students will just take the exam and they'll fail it. And again, that's just not how math works. You have to study for an exam in order to pass it, especially when it comes to final exams. This is a cumulative exam, meaning it's going to cover everything in the first half of this course. And so when you reach the end of any course, what tends to happen is your studying will intensify. The amount of work that you're putting into it will intensify. But a lot of students, they don't want that, obviously, so they just think, well, I'm not going to study, I'm just going to take the exam. And again, they end up just failing the test. So what I can do is I can give you practice tests to make sure that you do some studying, and I can demand that you do these practice tests. So these practice tests are not an option. You will do these practice tests before taking part 1 of the final exam in the next class, because if you don't, then you're going to fail the exam. These practice tests are the minimum that you need to prepare. Now, obviously, the final exam is the most important exam, so this is not something that you can just take lightly. You need to study harder now than any other time in this course. So that said, we're going to take a practice test right now together, as usual, as we always do. And then, of course, I'm going to give you a practice exam for homework that's also going to cover the first part of the course. Now, for this part 1 of the final exam, you can use a calculator, but not for graphing. So don't use the calculator for graphing. We're only going to use it for counting problems and maybe a few other things. So that said, let's start the practice exam. This is version 1, and as usual, I want you to attempt these problems on your own before watching me do them. So if you can do problem number 1, go ahead and do it. If you get stuck, that's okay, but you need to figure out if you're able to do this problem on your own. And if you can't do it on your own, what does that tell you? It tells you, well, you need to study this part of the course. If you can do it on your own, what does that tell you? Well, it tells you you may not have to study this part of the course. So that's the whole point of these practice exams, is to guide you when it comes to your studying. So these practice exams are a starting point for your studying. So try number 1, and when you come back, we'll do it together. Okay, we're back. So because this polynomial is written in factored form, we can see the x-intercepts. There are 2, -5, and pi. That's where the graph crosses, because if we plug in 2, we get 0. We plug in -5, we get 0. Plug in pi, we get 0, which makes f 0. That's the whole definition of an x-intercept. When the y value, remember f of x is the y value, when that's 0, you have an x-intercept. That's why these numbers are also called zeros of the function. So those are the x-intercepts, also called zeros, also called roots of the polynomial. Now, in order to figure out if the function crosses the x-axis or touches it at those x-intercepts, we have to look at the multiplicity, which is these numbers here, the exponents. So the multiplicity for the first 0 is 4. That's an even number. If it's an even number, then that means that the graph touches, but it doesn't cross. If we have an odd number, in the case of this x-intercept, or that 0, then that means that the corresponding graph, if we graph this polynomial, it's going to cross the x-axis at -5. And here we have 1 is the multiplicity. So that's again another odd multiplicity, so that means that the corresponding graph of this function crosses when x is equal to pi. So if you got that right, excellent. Go ahead and try number 2. When you come back, we'll do it together. Okay, we're back. So we don't know exactly what the graph is doing far to the left or far to the right, but we do know that in this region the graph is decreasing. Remember, when you're talking about a function increasing or decreasing, you're always referring to the movement from left to right as x values get bigger and bigger. So in this region here, which seems to be 1, 2, 3, 4, 5, 6, 7, we're starting at -7, and then we're going to -5. The function is decreasing because the graph is going down from left to right. It's also going down from left to right from 0 to 1, 2, 3, 4, 5, it looks like. So 0 to 5, it's decreasing. And we can put a union symbol there. So those are the intervals where the function is decreasing. Remember, when we're talking about increasing or decreasing, it's always left to right. So now we can see that the graph is increasing from -5 to 0 because the graph is going up in this region here from left to right. It's also going up from 5 to 7 in this region here. So if you got that right, excellent. Go ahead and try number 3. When you come back, we'll do it together. Okay, we're back. So we want to know the probability that we'll get either a coin made of silver or the coin will be a dime. And that's equal to the probability that we'll get a silver coin plus a probability that we'll get a dime minus the probability that we'll get both a silver coin and a dime. And the reason that is because these are not mutually exclusive events. Let me give you an example of an event that would be mutually exclusive. Let's say that we wanted to know the probability that that we would get either a dime or a quarter. Is it possible to get both a dime and a quarter? If you choose one coin, can that coin be both a dime and a quarter? No, that's impossible. That's a mutually exclusive. Those are talking about mutually exclusive events. You can't be a dime and a quarter at the same time. But you can be a silver coin and a dime at the same time. So getting a silver coin and a dime coin are not mutually exclusive events. Is that clear? You need to understand the difference. These are not mutually exclusive events, which means that we have to have this modification at the end here. If they are mutually exclusive events, we don't need this. So just be aware that sometimes you'll have problems where you just add the two probabilities and you'll be done. So the probability of getting a silver coin is 1/3, the probability of getting a dime is 4/9, and the probability of choosing both a silver coin and a dime is 1/5. So let's change the form of that fraction. 1/3 is 3/9. Add those up and we get 7/9. And so if we subtract these, we get 26 over 45. So if you got that right, excellent. Okay, so go ahead and try number 4, and when you come back, we'll do it together. Alright, we're back. So the probability that a coin selected from Lydia's collection will not be silver is equal to the probability, is equal to 1 minus the probability that a randomly selected coin will be silver. And we're given that information. That's 1/3. We're told up here the probability that a randomly chosen coin will be made of silver is 1/3. So we just subtract and we get 2/3. So that was a pretty easy problem. You got that right? Good. Okay, go ahead and try number 5. When you come back, we'll do it together. Alright, we're back. So this is the standard form of an ellipse. Actually, A should be here and B should be here in this case, because it's the major axis is vertical. So that's a standard form, and so now we just need to plug in. So let's find H and K. So 1, 2, 3, 4. Looks like the center is -4, 0. So that's H and K. So -4 and 0. Those are the coordinates of the center of the ellipse. Now A is half the length of the major axis. That's 1, 2. Alright, so we have 2 squared. B is half the length of the minor axis. So that is going to be 1 unit. So 1 squared. So now all we have to do is simplify that expression. So we have a double negative that becomes x plus 4 squared. And 1 squared is 1. Y minus 0 is y squared. 2 squared is 4. And we have our equation. So that was an easy problem. Have you got that right? Excellent. Okay, so go ahead and try number 6. When you come back, we'll do it together. Alright, we're back. Notice it says that repetition is allowed. Alright, so we're going to choose our first letter. What is our first letter going to be? Well, we have 28 options. For our second letter that we're going to choose, how many options do we have? Well, we still have 28 because repetition is allowed. Then we have 28 for the third option, for the fourth, for the fifth, and the sixth. So you don't have to actually write all this out if you don't want to. You can just write 28 to the 6th power. So this is an example where we do not have, or this is an example where we do have repetition. So 28 to the 6th power is a pretty big number. That's going to be let's write out the number. Looks like it's going to be 481,890,304 outcome variations. So these problems can be a little tricky, so you have to get used to them. That's the whole point of studying for this exam. So if you got that right, excellent. Go ahead and try number 7, and when you come back, we'll do it together. Alright, we're back. So in this problem, and by the way, I didn't mention, we have a number of choices to make. 1, 2, 3, 4, 5, 6 choices to make, and each choice has 28 options. So we're using the product rule. Okay, so we're also using the product rule in this problem. We have a number of choices to make. How many choices? 4 choices. Because Alexander is going to give 1 card to each of his 4 children. So the first choice he's going to make is what card does he give to the first child. The second choice he's going to make is what card does he give to the second child. And how many options does he have for each choice? Well, the first choice has 50 options. And by the way, we're going to write P 50 comma 4, which also can be written as 50 P4. A lot of different ways to write it. In your calculator, you're going to see, I believe, NPR like that, if I remember correctly, if you're using a TI-84 Plus or any TI. Okay, so you have 50 options for the first choice, but you're not allowed repetition. In the previous problem, we had repetition. You could use the same letter again and again, but now you can't use the same card over and over again, because once you give a card to the first child, that child has that card. You can't give it to any other child. So now for the second choice, you have 49 options. And then 48, 47, and there you go. So now it's important to understand that both of these scenarios count permutations. They count the different orderings. So if Cecilia gets the ace of diamonds, and then Bobby gets a 3 of spades, that's different. That's a different situation if Cecilia gets the 3 of spades and Bobby gets the ace of diamonds. So you're counting the different permutations, the orderings, in both of these scenarios. But remember, sometimes when you're counting groups, for example, groups of people, if you're going to choose a group of 10 people to be on a committee, you're not going to count the permutations or the orderings of the people, because a group is a group. Or maybe if you're going to have a poker hand, it doesn't matter what the order of the cards is. All that matters is the combination or the grouping. That's when you use 50C4 instead of P4. It's C, combinations or groupings. Now you can do this directly in your calculator, or you can use the function on your TI-84 Plus, and I'm sure you have this function on your Hewlett-Packard or Casio or whatever calculator you're using. You may have the function on your scientific calculator, but it's not going to be on normal calculators. So with the TI-84 Plus, you can enter 50, then push the math button at the upper left, then the right arrow key to PRB, go down to NPR, not NCR. NPR, this is number 2. Press enter. Then you're going to enter 4, and at this point, what you should have in your calculator is 50 NPR 4. Then press enter, and you have your answer. So again, you don't have to do that. You can just do this directly in your calculator without going to the actual function but we have 5,527,200, and so that's 5,527,200 outcome variations. So if you got that right, excellent. I'm going to move this down a little bit. So we have outcome variations. If you got that right, good job. Okay, on to number 8. Go ahead and try number 8. When you come back, we'll do it together. Alright, we're back. So let's write the standard form for the equation of a circle. Alright, now what do we know? Well, it says that the center is on the line x equals 2. So let me draw the line x equals 2. That pink line there, that's the line x equals 2. Now, if the center of the circle is on that, then that means your circle could look like that, or it could look like this. But what it tells us is the x value, or the x coordinate of the center of the circle. So that tells us the h value is 2. Okay, now think about that. If you're not sure what we're talking about, think about that for a little bit. That it tells us the h value, so h is 2. Now, we have a point on the circle, 4, 3. So that means that we can plug in 4 for x, and we can plug in 3 for y. We're also told that the radius is 2, so we can plug in the radius. So we have all the information that we need except the y value of the center of the circle, the y coordinate of the center of the circle. So now let's simplify here. I'm going to subtract 2 squared from both sides, and we're left with 3 minus k squared is equal to 0. If we square root both sides, we get plus or minus square root 0, right, which is just 0. And k is obviously equal to 3. The square root of 0 is just 0, and plus or minus 0 is just 0. So the only solution will be 3 for k. So now we're done. We can just write the standard form of the circle. Two squared is 4. Okay, now let's graph the equation. So the center is 2, 3. That's here. And the radius is 2, so we go up 2, down 2, to the right 2, and to the left 2. And then we connect the dots. Here a circle doesn't have to be perfect. So there you go. If you got that right, good. Okay, let's try number 9. So go ahead and try part 1 of number 9. And when you come back, we'll do it together. Okay, we're back. So we need to write this in recursive form. So a term, for this particular sequence, a term can be found by taking the previous term, which we notate as a subscript n minus 1, and multiplying it by negative 1/2. So there you go. That's the nth term. Now, that tells us how to find a term given the previous term, but it doesn't really define the sequence completely because we don't have a starting point, right? So we need a starting point. So I'm going to write a1 is equal to -1/2. So, and the reason I did that is because it tells us specifically, show the value of the first term. So that's what we mean when we do that. So you can write braces around that if you want. But if you just want to rectangle that, that's okay. So if you got that right, excellent. Go ahead and try part 2 of this problem. When you come back, we'll do it together. Okay, we're back. What is the sum of all of the terms? So this is 3 of the terms, but notice the ... That means it just keeps going on indefinitely. And really what that means is that the sequence is actually infinite. It just keeps going on and on and on and on. So we want to know the sum of all the terms, but that's impossible. You can't find the sum of all of the terms of a sequence. But actually, in some cases, you can. In this case, you actually can do it. If the sequence is approaching 0 and it's geometric. Okay. If the sequence is geometric and it's approaching 0, then you can find the sum of all the terms. So remember, we have a formula for that. It's the first term divided by 1 minus the common ratio. Alright, so the first term is -1/2. The common ratio is -1/2. So now all we have to do is simplify this, and we have the sum of all the terms. So we have -1/2 over 3/2. And a lot of students have trouble with this basic math, but at this point you really shouldn't be having trouble with this. This is precalculus, so you should know what to do. I know a lot of students still struggle with this, but you need to know what to do. What does that fraction mean? It means division, right? There's a lot of different ways you can think about this, but students typically prefer to think of that as a division symbol, and you're just dividing fractions, right? So you flip the divisor and then change the purple division symbol to multiplication, and then we have negative 1/3. That is the sum of all the terms. There's an infinite number of terms. So if you got that right, excellent. So you may want to take a picture of this sequence here, because we have part 3 and part 4. What is the 30th term? Okay, so now we're looking for the nth term of a geometric sequence. The nth term is equal to a1 times r to the n minus 1. Now you might be thinking to yourself, am I supposed to remember all this? And the answer is yes, you have to memorize that. I know that it's not fun. I know that you don't want to, but you're going to memorize all these formulas. You need to know that from memory. You're not allowed to have a cheat sheet on the exam. So we're looking for the 30th term. So the first term, if you recall, is -1/2. The common ratio is also -1/2. And we plug in 30 for n. So then we get -1/2 times -1/2 to the 29th power. So that becomes -1/2 to the 30th power, because you have 29 -1/2s, and you're multiplying by one more, so you get -1/2 to the 30th, and we're just going to leave it like that. Notice it says up here, you may leave your answer in exponential form. That's because this number is so small that it's better to just write it in exponential form. Okay, now part 4, what is the sum of the first 30 terms? Now again, if you didn't get a picture of the sequence that we're talking about, go ahead and get a picture of that. And I want you to try number 4. When you come back, we'll do it together. Okay, we're back. So remember the sum formula, or the formula for the sum of the first n terms of a geometric sequence is a1 times 1 minus r to the n over 1 minus r. Now again, do you have to memorize that? Yes, you do. I know it's not fun, but you have to do it. The first term is negative 1/2. The common ratio is negative 1/2, and we're adding, whoops, yeah, that's right, 30. We're adding the first 30 terms, and we have 1 minus negative 1/2. Probably best to write that fraction in parentheses. So now we're not going to be able to simplify that completely, but there's a number of things that you can simplify. So first of all, this is an even power, right? 30 is an even power. So that means when you raise a negative number to an even power, the negative is just going to disappear. So we can actually just write that as 1 minus 1/2 to the 30th power. Now this is a double negative, so it becomes 1 plus 1/2, and that is obviously going to be 3/2. Okay, so now it's very important to understand that we have a fraction here, and we have a fraction here. And we're multiplying the green and the yellow fractions, right? Now, how do you multiply fractions? Well, again, that's an arithmetic concept. This is precalculus. You learn how to multiply fractions in an arithmetic course. That was like 5, 6, 7 courses in the past. So you should know how to do this by now. So to multiply fractions, you multiply the numerators. So 1 times all of that, or let's say negative 1 times all that, is going to be negative 1 plus 1/2 to the 30th. Then we're going to multiply 2 by 3/2, and you end up with 3. So the sum of the first 30 terms is equal to that expression. And notice it says again, you may leave your answer in exponential form. It would be very difficult. I mean, we could do it, I guess, but this number here is almost non-existent. It's so small. So you can see as the number of terms approaches infinity, this term would actually just disappear, and you'd end up with a sum that is equal to negative 1/3. That's why our infinite sum in part 2 of this problem was just negative 1/3. So if you got that right, excellent. Again, if you want to reference the original problem, here's the original sequence. So go ahead and try number 10. When you come back, we'll do it together. Alright, we're back. So let's start with our combinatorics. So 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. Then we're going to have x cubed raised to the 4th, x cubed raised to the 3rd, x cubed raised to the 2nd, x cubed raised to the 1st, and x cubed raised to the 0. Then we're going to have negative 2 raised to the 0 going in the opposite direction when it comes to the powers. Then the first power, then the second power, then the third power, then the fourth power. I know it's hard to fit all this on the screen, but you just got to do the best that you can. You may have to do some erasing, that's okay. Okay, so that's about it. we just have to add plus signs. Make sure you go back over this stuff and avoid any mistakes. Now we may need to use our calculator to find these values here, but some of the values, like 4, 0, remember that's pronounced 4, choose 0. So how many ways can you choose 0 things out of 4? Well, that's just defined to be 1. It's not really a concept that makes any sense. It's just defined to be 1. So now we're going to use exponent rule number 5. You can look that up in my intermediate algebra course. That's exponent rule number 5. We multiply the powers. Negative 2 to the 0 power. Anything raised to the 0 power is 1. That's exponent rule number 7. How many ways can you choose one thing out of 4? Well, obviously that's 4 different ways. Exponent rule number 5 again. Now we have exponent rule number 6. Anything raised to the first power is just whatever that number is. Now, how many ways can you choose 2 things out of 4? Now, you may have to use your calculator. You could probably figure that out in your head, but it's easier to use the calculator. So if you're using a TI-84 Plus, again, if you're using a Hewlett-Packard or a Casio, I can't tell you how to do this. But if you're using a TI-84 Plus, you can enter 4. Then at the upper left, push the math button. Then the right arrow key to PRB. Then go down to number 3, NCR. Press enter. And then press 2. And you should have 4 NCR 2. That's what you should see in your calculator. Then press enter. And you get 6. So there's 6 different ways to choose 2 things out of 4. Then we're going to use exponent rule number 5 again. And raising to the second power, we get 4. How many ways can you choose 3 things out of 4? Well, again, press 4, the math button at the upper left, right arrow key to PRB, go down to NCR, press enter on that, then press 3, and you should have 4 NCR 3. Press enter, and we get 4. There's 4 different ways that you can choose 3 things out of 4. Using exponent rule number 6, anything to the raised to the first power is just whatever that number is. Or you could use exponent rule number 5. Negative 2 to the third power is negative 8. How many ways can you choose 4 things out of 4? That's 1. Using exponent rule number 5, negative 2 to the fourth power is positive 16. So we did that kind of quickly, so let's go back and check to make sure that we did everything right. It's very easy to make mistakes when you're doing math problems, as you've probably figured out yourself. So let's go back and make sure that we did everything right. Everything looks correct, so I think we're ready to write the final answer. So we have x to the 12th minus 8 x to the 9th plus 24 x to the 6th minus 32 x cubed plus 16, because x to the 0 is just 1. So if you got that right, excellent. Okay, so go ahead and try number 11. When you come back, we'll do it together. Alright, we're back. So there's a lot of terms in this sequence. So we don't know what to do here. There's just too many terms. We don't want to count or add up all of the terms because there's just too many. But if we analyze this sequence, what we find is that it's an arithmetic sequence. Now, how do we show that? Well, one way we can figure it out is just by looking at that expression. We can see it's arithmetic just by looking at the expression. If it were a geometric sequence, it would look like this, with an n in the numerator. It might have 3 to the n or 3 to the n minus 1. Those are geometric. But if you see something like this, or like this, or like this, or like this, or this, these are all arithmetic sequences because they're linear expressions. Another way to determine that it's arithmetic is just by plugging in numbers and looking at the progression of the terms. So we're going to start with 2 because it says to start with 2 there. Plug in 2 for n. Then obviously we're going to plug in 3, and we're just going to keep moving up the integer list. And this sum just keeps going on and on and on and on. So now let's calculate. So we have 6 minus 1 is 5. 9 minus 1 is 8. 12 minus 1 is 11. 15 minus 1 is 14. So that is the sequence. So let's see if we can recognize this as an arithmetic sequence. And of course we can, because we're just adding 3 each time. If you add or subtract the same number each time, in this case it's 3, 3, 3, 3, then it's an arithmetic sequence. If you're multiplying by the same number again and again and again, then it's a geometric sequence. And just be aware, you can multiply by a whole number for a geometric sequence, or you can multiply by a fraction. So in this case, the numbers would be getting smaller. In this case, they would be getting bigger. But we don't have a geometric sequence. We have an arithmetic sequence. So now that we know it's an arithmetic sequence, and we're looking for a sum, well, we can use our sum formula. So now we go to the second part of the problem, where we write our sum formula for an arithmetic sequence. That's n over 2 times the first term plus the common difference times the number of terms we're adding minus 1. Now again, do you have to memorize that? Yes, you have to memorize that formula. Now this is the part where students are typically going to make a mistake. Alright. How many terms are we adding up? A lot of students would say, well, we're adding 72 terms. No, we're not. And the reason we're not adding 72 terms is because we're not starting with n equals 1. We're starting with n equals 2. If we were starting with n equals 1, then there would be 72 terms. That's very important to remember for the test. If we were starting with n equals 1, there would be 72 terms. But because we're starting with n equals 2, there's only 71 terms. So we're adding the first 71 terms to calculate the value of this expression. So n is 71, and the first term is 5. Whoops. 2 times 5, that should be. The common difference, obviously, is 3, and n is 71. So now all we have to do is simplify that expression, and we'll have our answer. So, we have 71 over 2 and 10 plus 3 times 70. You don't have to show the steps for this if you don't want, but we're just being thorough. So we have 10 plus 210, and that becomes 71 over 2 times 220. That becomes 71 times 110. Again, you can just enter all this stuff in your calculator. Just be aware that if you enter this in your calculator, there's a big risk that you'll enter it in incorrectly if you don't know how to use your calculator. So if you trust yourself to do the order of operations properly, then you might want to do that in your head, or do it part by part, or step by step. So 71 times 110 is 7,810. So that is the sum here. That's the value of that expression. If you got that right, excellent. Okay, on to number 12. Go ahead and try number 12. When you come back, we'll do it together. Alright, we're back. So it says write a polynomial function in standard form with real coefficients that has the following zeros, leading coefficients. So we'll call this f of x. So we want the leading coefficient to be -1. So I'm going to write a -1 there. We know that x minus 2 is a factor because of the factor theorem. Remember the factor theorem? The factor theorem tells us that if 2 is a 0, then x minus 2 is a factor of the corresponding polynomial. And the converse of that is true also. If x minus 2 is a factor, then that means that 2 is a 0. But I is also a 0, so that means x minus I is a factor of the polynomial. Now notice up here it says that we're supposed to write a polynomial that has real coefficients, and it has degree 3, so we need another factor. But what factor are we going to write? Well, remember the complex conjugate theorem. If we have real coefficients for our polynomial, meaning when you write your polynomial might look like this. This is not our polynomial. I'm just writing an example. So if these coefficients are all real numbers, there's no i's. That's what they mean when they say real coefficients. So if we want a function with real coefficients, and one of these zeros is I, then that means in order to get rid of that I, so that we have real coefficients, we need a x plus I factor. So if I is a 0, then negative I is also a 0, if we want to have real coefficients. Okay, so now we have three zeros, which means that we're going to have a degree 3 polynomial. We've got our leading coefficient, and now it says write the function in standard form, which means that we just need to expand that expression. So let's go ahead and do that. So I'm going to multiply the second two factors. So we have x squared and then plus xi minus, or we can say ix, it really doesn't matter, ix minus ix, and then the last factor is going to be negative I squared. You have to be careful when you multiply the L term of FOIL. Okay, and as you can see, some of those numbers just cancel out. So we're left with x squared minus, these just cancel out, and this here, that becomes negative 1. That's the definition of I. It's a number that when you square it, you get a negative. That's why it's called imaginary. So now we have x squared plus 1. So we have to keep going to put this polynomial in standard form. So now we're going to use FOIL again. So we get x cubed plus x minus 2x squared minus 2. I'm going to write the polynomial in descending order of powers. So we have negative x cubed positive 2x squared minus x plus 2. So there is the polynomial in standard form, if you got that right. Excellent. It has degree 3. It has a leading coefficient of -1. And it has those zeros, 2 and I. And it also has real coefficients. You see this green up here? That's real, that's real, that's real, that's real. There's no i's. Okay, so try number 13. And when you come back, we'll do it together. Alright, so we have to make sure that we do this correctly. You have to write both of these polynomials in descending order of powers. And if you don't do that, you're not going to get the right answer. Long division doesn't work unless polynomials are written in descending order of powers. So if you forgot to do that, that's okay, but just go back and do it correctly. Okay, so now we'd like to use synthetic division because that's the fast way to do this, right? Using synthetic division, but we can't because the divisor is not in the right form. The divisor has to be a very simple binomial x minus a, or x plus a if we assume that a is positive. So let's go ahead and divide. You don't have to use different colors, but I'm going to use different colors. So x times what is equal to x to the 5th power? X times what is equal to x to the 5th power? Well, that's just going to be x cubed. Alright, so x cubed times all of this, that's the second step, is going to be x to the 5th power. So the first step is figure out what this number is going to be. The second step is take that number and multiply it by the divisor. The third step, well actually we have to keep going here. So x cubed times the whole divisor, so that's going to be plus 2x to the 4th minus x cubed. Alright, so first step is what is this number? Second step is multiply that number by the divisor. And now we go on to the third step, which is subtract. So x to the 5th minus x to the 5th is 0. That should be 0. If it's not 0, that means you did something wrong. Now, we're going to subtract 2x to the 4th, but there's no 4th power up here. So that means we just write it as negative 2x to the 4th. And we're going to subtract negative x cubed, but there's no x cubed up here. So that means we're just going to write plus x cubed. And we have a negative x squared, but there's no x squared down here. So we're just going to write the result when we subtract nothing from negative x squared. And we have 3. We're going to subtract nothing from 3, so we have 3. Okay. Now, you can line these up differently if you want, but you don't really have to. So now we're going to start the whole cycle over again. So again, there's 3 steps to every cycle. Figure out what this number is going to be, multiply by the divisor, and then subtract. Again, 3 steps. Figure out what the number is going to be, multiply it by the divisor, and then subtract. It's always 3 steps. So now we're going to start another cycle. So x squared times what is equal to negative 2x to the 4th power? X squared times what is equal to negative 2x to the 4th power? X squared times what is equal to negative 2x to the 4th power? Well, that's going to be negative 2x squared. Negative 2 x squared. So that's the first step of the cycle. Now we're going to multiply that by the divisor, and we get negative 2x to the 4th. It should be the same as this term up here, negative 4x cubed, and positive 2x squared. So that was step 2. Step 1 is figure out what this is going to be. Step 2 is multiply that by the divisor. And step 3 is subtract. So let's make sure that we did all this correctly. Looks like we did. So now we're going to do the third step. We're going to subtract. So these cancel out, of course. And now we're going to subtract negative 4x cubed from x cubed. So that's going to be a double negative. So that's actually going to be 5x cubed. I know what you're thinking. You're thinking, whoa, 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 that's not right. That is correct because, again, this is a negative number. You're subtracting it, so it becomes a positive number. I know that's very confusing. But in this case, we're going to have negative 3x squared. And then 3 minus nothing is 3. Because this is not a negative. It's a positive. So we have negative 1 minus 2 is negative 3. Again, I know that's very confusing. Math can be very confusing, but you're just going to have to get used to that. It's very confusing. So now we start the whole cycle over again. Step 1, figure out what we're going to write here. X squared times what is equal to 5x cubed. Now I know what you're thinking. You're thinking, how do we know when to stop all of this? Well, we stop when the degree of the remainder is less than the degree of the divisor. What does that mean? It means that this number has to be smaller than this number. It's not smaller yet. It can't be equal. It has to be smaller. So we have to keep going. So again, what number times x squared is equal to 5x cubed? Well, that's going to be 5x. So we read our 5x there. That's for step 1 of the cycle. Step 2, multiply. And we get 5x cubed plus 10x squared minus 5x. Step 3 is subtract. So these cancel out. If they don't cancel out, that means we did something wrong. We get negative 13x squared, and that's a double negative, so that becomes positive 5x. And 3 minus nothing is 3. So we still don't have a degree that's less than the degree of the divisor. So we have to keep going. So let's start the cycle over again. X squared times what is equal to negative 13x squared? Well, obviously that's just going to be negative 13. That's step 1. Figure out what this number is going to be. Step 2, multiply that number by the divisor. So we have negative 13x squared minus 26x plus 13. Then we're going to subtract. These cancel out as they should. We have a double negative, so we end up with 31x, and 3 minus 13 is negative 10. So now the degree of the remainder, which is 1 in this case, is smaller than the degree of the divisor. So that means we're done. We just have to write the final answer. So the final answer is this expression up here. So let's write that. X cubed minus 2x squared plus 5x minus 13. But then we have to add the remainder, 31x minus 10, divided by the divisor, x squared plus 2x minus 1. That is the final answer. So if you got that right, excellent. If you had some trouble with that, that's okay. That means that you need to do some practice problems. That's okay. Alright, so try part 2. Part 2 asks, can we use synthetic division on this problem? And I already answered that question, actually. But you have to explain that in your own words. So see what you can do for part 2. When you come back, we'll do it together. Okay, we're back. So, can you use synthetic division? No, because the divisor is not in the right form. We can only use synthetic division when we have a binomial that is a degree 1 binomial. That's one way to describe it. Another way to describe it is the divisor. You can just say the divisor is not in the right, well, I wouldn't say that it's not in the right form. It's not the right kind of divisor. The divisor is not a binomial of the form x minus a. Technically, you would need to define what a is, but I'm not going to make you do that. That's good enough. As long as you can explain in a way that makes sense, that's all I really expect you to do for that problem. So if you have x minus 2 or x plus 3, something like that, then we could use synthetic division. But we don't have that situation in this problem. So if you got that right, good. Okay, go ahead and try number 14. When you come back, we'll do it together. Alright, we're back. We need to use the rational zeros theorem. So you don't have to write P and Q if you don't want to. So P is 8. So we have 1, 2, 4, and 8 are the factors of P. And the factors of Q are 1 and 2. So then, of course, we want to find all the possibilities for P over Q. Those are going to represent the possible or potential rational zeros. And again, you don't really have to do any of this stuff. You can just think of these numbers in your head. Just plug in 1, plug in -1, and proceed from there. Now we need to write plus or minus symbols as we do this. So let's take 1, and well, let's take all these numbers and divide by 1. So we get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So we divided all these numbers by 1. 1, 2, 4, 8. So now let's take those same numbers and divide by 2. So then we obviously get plus or minus 1/2. Sorry, my computer's going kind of slow. And then 2 divided by 2 is 1. We already have that one. And 4 divided by 2 is 2. We already have that one. And 8 divided by 2 is 4. We already have that one. So those are all the potential rational zeros, if there are rational zeros. And we couldn't really do this problem unless we had rational zeros, so there has to be at least a few rational zeros. So again, you can just plug in 1 or -1. That's always going to be a potential rational zero. And if those don't work, then you would need to use the rational zeros theorem to find the other possibilities. So let's start with 1. and we're going to check that. It's too much work to have to plug in and show all the stuff, so we're going to have to do this in our heads. So plug in 1, and you get 2 minus 9 is negative 7, plus 14 is positive 7, minus 12 is negative 5, plus 8 is 3, if I did my math correctly. So what that means is the answer is no. That didn't work. So now we move on to negative 1. So negative 1 to the 4th power is 1 times 2 is 2. Negative 1 to the 3rd power is negative 1 times negative 9 is 9. This is really tedious to have to say this over and over again, so again, you can just do this in your head. Plugging in negative 1, we get plus 14, plus 12, plus 8. Obviously, that's not 0. None of the terms ended up being negative, so it just doesn't work. So that didn't work. That's okay. Well, what do we have next? Well, we have positive 2. So let's try positive 2. Plug in 2, and you get 32. I'll let you figure out these numbers yourself, but remember, you have to use the order of operations. You have to raise to these powers first and then multiply by the coefficients. So that's something that you should know by now in the curriculum. That's just basic math, basic order of operations. Plugging in 2, we get 56, and then minus 24, and then plus 8. Now, if you want to do this in your calculator, you can do it. That's okay. I don't expect you to do everything in your head or on paper. So if you add all these up, we get 0. So what that means is we just proved that 2 is a 0. But remember, if 2 is a 0, then that means by the remainder theorem, or excuse me, the factor theorem, that x minus 2 is a factor. And if x minus 2 is a factor, then we should be able to divide this polynomial by x minus 2 and get a reduced form that does not have a remainder. I know that's a lot to think about, but let's take this and go up here. And we're going to use synthetic division. And we're going to divide by x minus 2. The coefficients are 2, negative 9, 14, negative 12, and 8. So I got those coefficients from up here. And you really have to be careful that you don't write the setup incorrectly. In this case, we're not skipping any powers, but sometimes you'll be skipping powers. We'll find that in a different problem in today's exam. So let's bring the numbers down. 2 comes down. Multiply these numbers, you get 4. This number always comes down first. Multiply these numbers, you get 4. Then add these numbers, you get negative 5. Then multiply these numbers, you get negative 10. Add these numbers, you get 4. Multiply these numbers, you get 8. Add these numbers, you get negative 4. Multiply these numbers, you get negative 8. And add these and you get 0. So the fact that we got 0 means that we did something correctly. So what does this mean? Well, what it means is that our original function is equal to x minus 2 times 2x cubed minus 5x squared plus 4x minus 4. All right. So we're finding the zeros, and we're also going to write the multiplicity. Now we don't have to write it. The problem doesn't tell us to write this function like that, but it just kind of helps us to understand what's happening. We found one of the zeros is 2. But now we need to use the rational zeros theorem on this expression here to figure out if, to figure out another 0, because we don't know how to factor this. We can't factor it by grouping. So let's now take this expression here and plug in another number. So let's try plugging in 2 again, see what happens. So 16 minus 20 plus 8 minus 4. If we plug in 2, we get that. And it actually worked. We got 0. If you add all those up, you get 0. So 2, it actually worked twice. So we tried it again, it worked again. So that means we're going to divide that blue expression. And I'm going to erase this because I don't want to confuse things. So now we're going to use synthetic division again. And we have these coefficients 2, -5, 4, -4. And we're going to divide again by 2, or x minus 2 I should say. So we're going to bring down the 2. We always start by bringing that number down. Then we're going to multiply these numbers and we get 4. Then we're going to add these numbers, we get -1. Then we're going to multiply these numbers, we get -2. Then we're going to add these numbers, we get 2. Then we're going to multiply these numbers, we get 4. And we're going to add these numbers and we should get 0 if we did it correctly, and we do. So now, what does this mean? It means that f of x, our original function, is equal to x minus 2 times another x minus 2, because 2 worked twice, times whatever is left over. Now, how in the world are we supposed to figure out what's left over? Well, it's right here. That's why we're using synthetic division, is because it tells us what's left over. So we have 2 x squared minus x plus 2. And notice that the degree is 1 less than what we started out with each time we use synthetic division. So we started out with 4, then we went down to 3, then we went down to 2. And the reason for that is because you're dividing by a degree 1 polynomial. These are degree 1 polynomials, x minus 2 and then x minus 2 again. So we found a 0, and we see that that 0 has multiplicity 2 because there's 2 of those factors, but we have to keep going. Notice up here it says find all the zeros, real or imaginary. So we have to keep going. Now we can try to factor this expression here, but we don't know if that's going to be factorable. And so I'm just going to use the quadratic equation to see if we can factor that. So x is equal to -b plus or minus root b squared minus 4ac. The discriminant actually tells us if we can factor. The discriminant is this expression here. If that number is negative, or if that number is not a perfect square, then that means that we can't factor very easily. So if we plug in numbers, we get -b plus or minus root b squared minus 4 times a times c, and all of that is divided by 2 times 2. So then we have 1 plus or minus root 1 minus 16 all over 4. So we need to go one more step. Finally, we have 1 plus or minus root negative 15 over 4. So you can see that the remaining zeros are actually going to be imaginary because the discriminant is a negative number. It's negative 15. So what does this tell us? It tells us we can't factor this expression. We can't factor it very easily, that is. So I'm going to write the function so we can see what's going on here. We have x minus 2 squared times x minus 1 plus, and I'm going to take the negative out of the root as an I, 1 plus I root 15 over 4. And then we have x minus 1 minus I root 15 over 4. So believe it or not, that is the factored form of the polynomial up here. Now the problem doesn't tell us to write it in factored form, but I'm just writing it so you can see the multiplicity of each zero. So as you can see, we have 4 zeros. 2 of the zeros are distinct, and 2 of them are what we call repeated zeros. So it says here, find the zeros. So let's write the zeros. We have 2. We have 1 plus I root 15 over 4. And we have 1 minus I root 15 over 4. So we found all the zeros. But it also says write the multiplicity of each zero. So I'm going to write m is equal to 2. The multiplicity is the exponent. M is equal to 1, because the exponent of this factor is 1, and the multiplicity of this last 0 is also 1. So we have the zeros and we have the multiplicity of each of the zeros. Now I know what you're thinking. You're thinking that was really involved, and it is involved, but it doesn't have to take that long. As long as you know what you're doing, you can get through it a lot quicker than what we just went through there. So problem number 15 is going to be a lot easier. So go ahead and try number 15. When you come back, we'll do it together. Alright, we're back. So to find the end behavior of this function, we only need to analyze the first term, because it's a polynomial function. The first term determines what's going to happen to it, because this fourth power is going to increase a lot faster than any of the other expressions. So as x approaches infinity, meaning as x gets really big, what's going to happen to f of x, the y values? So if we plug in a really big x value and raise it to the fourth power, we get a bigger value. And if we multiply it by 2, we get an even bigger value. And so as you can see, as x gets really big, this leading term gets really big in the positive direction. But now we want to know what happens to the function as x approaches negative infinity, meaning as we get really big negative numbers. What happens to the y values? So again, what this is telling us is what happens to the y values as the x values get really big, either positive or negative. So let's go to this leading term again and plug in a really big negative number. If we plug in a really big negative number and raise it to the fourth power, we're going to get a bigger number, but it's going to be positive. And multiply it by 2, it's going to stay positive. So that means that as we plug in bigger and bigger negative values, the function is going to, the y values are going to get bigger and bigger in the positive direction. So what this means is that as we go to the right, the graph is going to go up, and if we go to the left, the graph is also going to go up for really big positive values or negative values. So if you got that right, good. For number 16, state the maximum number of turning points of the graph of the function in problem number 14. So go ahead and do number 16. When you come back, we'll do it together. Okay, we're back. So the degree of the polynomial function is 4, and the maximum number of turning points of the corresponding graph is 1 less than 4. So it's going to be 3. So if you got that right, good. There's no work really that you need to show for that. If you want to, you can say 4 minus 1 is 3, because that's how we calculate it. But I don't really care, to be honest with you. Okay, go ahead and try number 17. There's 2 parts to number 17. When you come back, we'll do it together. Okay, we're back. So what is the probability that all 3 marbles will be blue? So probability of blue, blue, blue. Well, that's the number of ways that you can choose 3 things out of 8, because there's 8 blue marbles, divided by the number of ways you can choose 3 things out of a total of 20. Why 20? Because we have a total of 20 marbles. So how many ways can you choose 3 things out of 20? That's the sample space down here. And the number of ways you can choose 3 things out of 8, that's the outcomes that we want. The number of ways we can choose 3 blue marbles out of 8 total blue marbles. So let's go to our calculators. And if you have a TI-84 Plus, you're going to press 8 and then the math button at the upper left and the right arrow key to PRB, down arrow key to number 3, press enter, and you should have 8 NCR, and then you're going to enter 3. So you should have this, and then press enter, and it gives you 56. So that's how you do it if you have a TI-84 Plus, or pretty much any TI Texas Instruments calculator will be a similar method. If you're using a Hewlett-Packard or a Casio or something else, then you'll have to figure that out on your own. Now, most simple calculators don't have these functions, but if you have a scientific calculator, it's a good chance that it'll be able to do this. If you have a graphing calculator, it's pretty much a guarantee. But remember, you should be using a graphing calculator for this course. If you don't have one, you'll need that. So enter 20, the math button at the upper left, right arrow key, down to number 3. So you should have 20 NCR, and then enter 3. So this is what you should have, and then press enter. You get 1,140. Okay, so now I'm going to divide both sides of that fraction by 4. And we get the following. So if you got that right, good. What is the probability that 2 marbles will be green and 1 will be blue? So the probability of 2 green and 1 blue. We know the sample space is how many ways you can choose 3 things out of 20. We're going to choose 2 green marbles, so we want to know all the ways that we can choose 2 green marbles out of the total number of 5 green marbles. And for each one of those scenarios, we have the number of ways that you can choose 1 blue marble out of 8. So we're using the product rule here. You see that? You have to make a choice here, and you have this many options, but then you have to make a second choice, and you have this many options. We already know the sample space is 1,140. You can enter that value into your calculator. 5 choose 2 is 10, and the number of ways you can choose one thing out of 8 is obviously 8. So we have 80 over 1,140, and that reduces to 8 over 114, and we can divide by 2 and we get 4 over 57. So if you got that right, excellent. So that was a combinatorics problem, or a grouping problem, where the order of the objects doesn't matter. Okay, so I want you to try number 18, and when you come back we'll do it together. Alright, we're back. So I'm going to make this circle proximity sensors and this circle GPS. And there are 29 trucks that have both. And we want to know how many trucks have a proximity sensor but not a GPS. So we're going to subtract 29 from 69, and we get 32. Whoops, that was the second problem. I don't know why I started with that problem. How many trucks have a GPS tracker but not a proximity sensor? So that's going to be 38 minus 29. So sorry, I don't know why I started with part 2 there. But anyway, these are the answers that you should get. So we can put 9 here and 32 there. For part 3, how many trucks have either a proximity sensor or a GPS? So we basically just add up all those numbers. 32 plus 29 plus 9. And we get 70 trucks. How many trucks have neither a proximity sensor nor a GPS tracker? So there's 70 trucks that have either or. So if you count all the trucks that have either or, 70, there's a total of 150 trucks. So if we subtract 70, we get 80. That's all the trucks that don't have either a proximity sensor or a GPS tracker. So if you got those right, excellent. Okay, go ahead and try number 19. Number 19 uses this information here, and when you come back we'll do it together. Okay, we're back. So what is the probability of randomly selecting a truck that has a proximity sensor? So there's 61 trucks that have proximity sensors and 150 trucks total. There you go. What is the probability that a randomly selected truck will have neither a proximity sensor nor a GPS tracker? Well, there's 80 trucks that don't have either, and there's 150 trucks total. Divide by 10, we get 8 over 15. So if you got that right, good. So we know that there's 29 trucks that have both, and there's 150 trucks total, so there you go. And what is the probability that a selected truck will have either a proximity sensor or a GPS tracker? So that's 70 that have either or, and a total of 150, and that reduces to 7 over 15. So if you got those right, excellent. Okay, on to the next one. So now we're going to graph this here, and we know that this is not a parabola because we have more than one variable squared, but I'll let you figure this out. So go ahead and try number 20. When you come back, we'll do it together. Okay, we're back. So it has to be a circle or an ellipse or a hyperbola, but it can't be a circle because if it were, these two numbers would be the same. So it has to be a hyperbola or an ellipse. Turns out it's a hyperbola because if it were an ellipse, then both of these signs would be the same. But because they're different, it has to be a hyperbola. But the problem is we can't really graph it because it's not in a form that we recognize. So we need to get it in a recognizable form. So I'm going to group all of the x's together. And put the 44 on the other side. Then I'm going to factor out 4 in the first grouping, and I'm going to factor out 6 in the second grouping. That should be a negative 4y. Let's make sure we did that correctly. Okay, so now we need to complete the square in order to put this in the proper form. So I'm going to add 1 here. So I took this number, divided by 2, and squared it, and then I added it. I'm then going to take this number and divide by 2 and square it and add that number. Now, a lot of students, they make a big mistake here. They add 1 and 4. We added 1 and 4 this side of the equation, so we have to add 1 and 4 on that side of the equation in order to make the equation true. But we didn't really add 1 and 4 on this side of the equation. We added 4 and negative 24. So be sure that you don't make a mistake there. Again, that's negative 24 that we added, and we added 4. Okay, so now we have our perfect squares, so now we can factor what number multiplies to 1 and add what two numbers multiply to 1 and add up to negative 2. That's 1. And what two numbers multiply to 4 and add up to negative 4? That's negative 2 and negative 2. And we get 24 here. Or positive 24. And then we're going to divide both sides of that equation by 24 because we want in standard form we should have a 1 on the right side of the equation. So I'm going to divide everything by 24. I'm dividing both sides of the equation by 24. And so this fraction reduces to 1 over 6. You can take as many steps as you want to simplify this. This fraction reduces to 1 over 4. And then we have our 1. So now we have standard form of the equation. So now we can see where the center of the hyperbola is. It's 1, 2, which is there. And if we square root this number, that's the vertical that we move up, the vertical distance we move up and down to get the sides of our boxes, or our one box. Then if we square root this, we get 2.45 roughly. So that tells us the horizontal distance we're going to move to get to the sides of our box. Which will be about there and there. So I'm going to connect the dots and create our box. Now remember, when we're graphing a hyperbola, we use the box to help us graph the hyperbola, but the box itself is not is not the hyperbola. Now I'm going to draw the asymptote lines. Again, the asymptote lines are not the actual hyperbola. They're not our graph. They're just there to help us draw our graph. And now I'm actually going to draw the graph. Now notice that the x term comes first. So that means that the parabolas are going to be going off to the left and to the right rather than up and down. If the y term came first, then we'd be going up and down with our parabolas. The parabolas would be opening up and down. Alright, so we have a parabola on the left and a parabola on the right. Okay, so now we have our graph, so that part is done. And now I think about it, we really should be drawing these asymptote lines with dotted lines. I should have done dotted lines. Sorry about that. Because the asymptotes are not part of our graph, we really should stick to dotted lines. Okay, so we've got our graph, and we need to find the coordinates of the foci. So to do that, we need to draw a triangle to help us remember the equation that we need to find the distance from the center to the foci. So that is this triangle here. This length is B and this length is A, and C just happens to be the length we're looking for. If we rotate that side down, so C is going out this way, that's going to tell us where our focus is. Again, C is the hypotenuse of the triangle, but it's actually the distance. If I get a different color pen here, it's the distance from the center to the actual focus out here. So what does this triangle tell us? It tells us that our equation is actually it's the same thing as the Pythagorean theorem. It's a squared plus b squared equals c squared. So that triangle helps us to remember. A squared plus b squared equals c squared, and a is the square root of that number, and b is 2. If we solve for c, we get root 10. So what we're going to do is start at the center. The center is 1, 2. So I'm going to write 1 and then 2. But we want to move from the center to the right to get to our focus. So I'm going to add root 10. That's the c value, the distance from the center to the focus. So that is one of our foci. Now the other focus, which I'm going to call F2, is 1 minus root 10, 2. So we're starting from here and we're going to the left, so we have to subtract root 10. Okay, so now we're going to draw the equations of the asymptotes. So we're going to use point slope form. Our point is going to be the center because the center is on both lines. So we're going to have y minus 2 is equal to the slope times x minus 1. We just have to find the slope of the lines. And there's going to be 2 lines, 2 asymptote lines, right? 1 over here and 1 over here. They're just going to have different slopes. They're going through the same point. They're going to have different slopes. So what is the slope of a line? Well, if you... Sorry, that's Microsoft throwing us around. If you look at this line here, you can see the rise and the run. The run is 2, and the rise is root 6. Or the rise is 2 and the run is root 6. So 2 over root 6. Sorry, my computer's going kind of slow here. So 2 over root 6, but we can rationalize the denominator. Multiply both sides by root 6, and we get root 6 over 3. If you need review on that, you can go back to my beginning algebra course, or there's a lot of places in my curriculum where I teach how to rationalize denominators. Now for the other line going down, it's going to be the same rise and run, except we're going down, so negative 2 over root 6. The run is actually, or the rise is actually negative 2, and the run is still root 6. So negative 2 over root 6, multiply both sides of that fraction by root 6, and we get negative root 6 over 3, x minus 1. So that's the other equation of the asymptote. So if you got those answers, good. Okay. So go ahead and try number 21. When you come back, we'll do it together. All right, we're back. So remember, the procedure here is to get everything on one side. So I'm going to subtract this expression from both sides. And because they have a common denominator, I can just combine everything. Now we need to use this formula up here because we have the difference of 2 cubes. So if you rewrite this as x cubed minus 3 cubed, you can see that. So a is going to be x, and b is going to be 3. So we have x squared plus 3x plus 3 squared, which is 9, over x minus 1 times x plus 1. We have the difference of 2 squares down here. And we can't forget our inequality symbol. So the reason that we did that is because by factoring, we're going to see the x-intercepts of the corresponding graph and the vertical asymptotes, and those are the potential places where this expression changes sign. Why do we care about where it changes sign? Well, because we're trying to figure out the x values that make the expression greater than 0. So we're going to make a sign chart, and our special values are 3 and 1 and negative 1. Now I forgot to mention that this expression here we don't need to factor because there's nothing that you can plug in there to make that 0. Now how do I know that? Well, we can find the discriminant. That's a quadratic expression. C is going to be that value, A is going to be that value, and B is going to be that value. Whoops. And so we have 3 squared minus 4 times A times C, which gives us 9 minus 36, which is negative 27. It's a negative discriminant, which means that there's going to be a negative under the root if we try to find something that will make that 0. So that means that we don't have to factor that expression. You might be wondering, do I have to know what you're talking about here? Well, this is just basic information about quadratic expressions. That's how you figure out if you can find a real zero of a quadratic equation is you use the discriminant. So let's see here. Let's test everything. Now, when we test the signs, I'm going to use this expression. Why am I going to use that? Because it's just easier. So let's plug in 0 up here. If you plug in 0, we get a positive number. You can do the math quickly in your head. If you plug in 2, you're going to get a negative number. If you plug in 4, you're going to get a positive number. And if you plug in negative 2 over here, you're going to get a negative number. So that's the sign chart. That tells us what the solutions are. So now we can write the graphical solution. We're going to write open dots. Why open? Because it wants to know where the expression is greater than 0, not equal to 0. And we want to know where it's greater than 0, so I'm going to fill in those areas that make the expression positive, because that's where it's greater than 0. And so there you go. That's the graphical solution. Now in interval notation, the solution is going to be -1, 1, union symbol, 3, infinity. The reason we draw parentheses and not brackets is because, again, we have open dots. The inequality symbol doesn't say greater than or equal to. It just says greater than. So there you go. All right. So if you got that right, perfect. Okay, go ahead and try number 22. When you come back, we'll do it together. All right, we're back. So to find the asymptote curve, we have to use long division. Actually, we don't have to use long division. We can actually use. I just realized that we can actually use synthetic division because we have the right divisor. So let's set this up, and we're dividing by -3. Remember, it's the opposite sign if you're actually looking at the factor that you're dividing by, or the not the factor, but the divisor. So let's bring down the 1. That's the first step. Multiply these, you get -3. Add these, you get 3. Multiply these, you get -9. Add these, you get -13. Multiply these, you get +39. Add these, you get 15. Now notice that our remainder is not 0. That's okay because there's nothing that suggests that it should be 0. Let's just double check to make sure we got the right numbers there. Everything looks right. So now we can write the new form of this expression. The new form is x squared plus 3x minus 13 plus 15 over x plus 3. So we changed the form of this expression. Why did we do that? Because as x approaches infinity, this fraction approaches 0, and the graph approaches that expression there. So that's our asymptote curve. So that is the asymptote curve there. And we probably want to set it equal to y, so we know how we're we would graph that if we wanted to. Okay, and the y-intercept, all we have to do is let x equal 0. So f of 0, and you can just plug in 0 to all the x's, and we're left with negative 24 over 3, which is negative 8. So 0, negative 8 is the y-intercept. The vertical asymptote, this factor didn't cancel out, so that means that x equals negative 3 is a vertical asymptote. So x-intercepts, in order to find the x-intercepts, we need to factor, or we need to somehow factor this expression. We could use the rational zeros theorem, but it turns out we can actually use a grouping on this. So I'm going to factor out x squared from the first two terms. I'm going to factor out negative 4 from the third and fourth term. All right. So we have that over x plus 3, and then I'm going to factor out x plus 6. So we have x plus 6 times x squared minus 4 over x plus 3, and then I'm going to factor the x plus 4. So we have x plus 6 times x minus 2 times x plus 2. That's the difference of two squares, and that's all over x plus 3. So now we can see the x-intercepts. Now we didn't really need the denominator really, but we can see that negative 6, 0 is an x-intercept, and you can just write x equals, or you can write the actual point. I don't really care, but I'm just going to write the actual points. So those are all x-intercepts. So we got that problem right. Good. Okay, so let's go on to number 23. Go and attempt this problem. When you come back, we'll do it together. Alright, we're back. So I'm going to put everything, I'm going to put the y and the 26 on this side. We could actually graph the problem in this form, but I'm going to complete the square because I think it would just be easier for us to see what's going on. For parabolas, you don't necessarily have to complete the square, but I think that would be best. So we're going to add 9, and we're going to subtract 27. We're not going to add 9. We're going to subtract 27. Why is that? Well, because when we added 9, we actually added negative 3 times 9. So we're subtracting 27, and over here we get y minus 1 is equal to negative 3 times, we can factor this. What two numbers multiply to 9 and add up to 6? That's 3 and 3. So now our vertex of our parabola is negative 3, 1, which is about there. And let's choose maybe an x value. Let's choose negative 2, plug it in there, and if we solve, we get negative 2. So negative 2 is a point. We can use symmetry, connect the dots. Try not to make the area around the vertex too pointed. It's got to be a curve. So now we're asked to draw the directrix and write its equation, and also the coordinates of the focus. So P is the distance from the vertical, or the distance along the line of symmetry, this line here, from the vertex to the directrix, or from the vertex to the focus. And our equation is that, so all we have to do is plug in A. Now what is A? A is -3. That's that value there. So we get P is equal to -1/12. Don't really pay attention to the sign, that's not that important. So now we can draw our directrix. It's going to be so close to the vertex that we won't even be able to barely tell that it's apart. And the equation of the directrix is y is equal to the y value of the vertex, which is 1, but we're going to add 1/12 to go a little bit higher than that. So the equation is 1 and 1/12. The coordinates of the focus, we're going to go in the opposite direction, so our x value is going to be -3, our y value is going to be 1, but we're going to subtract 1/12. So our focus coordinates are going to be -3, comma 11/12. So we graphed it and drew the directrix and wrote its equation and found the coordinates of the focus. That says foci, but it should say focus. Sorry about that. Okay, so go ahead and try number 24, and when you come back, we'll do it together. Okay, we're back. So to find the whole, we're going to factor the denominator and as you can see, we have a factor that cancels out, so that tells us that x equals 3 is a location of a whole. Sorry, my computer's going slow here. So then I'm going to define a new function, which I'm going to call g of x, because when that factor goes away, it's not really the same function. It has the same exact graph. The only difference is that this graph is lacking a whole, whereas this one has a whole at x equals 3. Okay, so now this tells us that we have a vertical asymptote. Because that factor did not cancel out, we have a vertical asymptote at x equals -6. And because the degree of the polynomial in the numerator is less than the degree of the polynomial in the denominator, we know that there's a horizontal asymptote at y equals 0. So that's always true when the degree of the numerator is less than the degree of the denominator, if you're dealing with a rational function with polynomial expressions in the numerator and the denominator. Now for the y-intercept, all we have to do is just let x equal 0, and you can do that in your head. Let x equal 0, all these x's turn to zeros, and you get -3 over -18, but then you have a negative in front of it, so it ends up being -1/6. So the y-intercept is 0, -1/6. Okay, and what about x-intercepts? Well, there's actually no x-intercepts, because this reduced form here tells us that there's no x value that we can plug in that will make the numerator of the fraction 0. Now, we can make the numerator 0 up here, but that doesn't qualify because that's a whole. That doesn't mean that we have an actual x-intercept. So the answer for that one is none. And I guess we don't have to rectangle these because the problem isn't actually asking for that information, but we do need that information to graph this function. So we have a horizontal asymptote, we have a vertical asymptote, and we have a y-intercept at 0 and -1,6, so right about there. You see that purple point there? It's pretty close to the x-axis. Okay, so now we need to make a sign chart in order to know what exactly the graph is doing. We need some sort of a reference, and that's what the sign chart tells us. So x-intercepts and vertical asymptotes are where the graph can potentially change sign. We don't have an x-intercept, but we do have a vertical asymptote at -6. Now we need to plug in some value over here. Actually, I'm going to start over here. I'm going to plug in 0, and we'll see what the sign is going to be. Well, we already know that. That's going to be negative. So that part of the graph is under the x-axis because it's the y values are negative. Plug in a number over here. Let's try plugging in maybe -10, and it's kind of hard to plug it in up here, but we don't have to. We can actually plug it in down there. So plug in -10 and we get a positive number. Okay, so what that means is the graph of the function is above the x-axis to the left of that asymptote, but it's below the x-axis to the right of that asymptote. And you can get more accurate if you really want to plot some more points, but I don't require you to do that. We need arrows on both sides of these curves there. So that's number 24. That's pretty much all you need. If you got that right, good job. Go ahead and try number 15. When you come back, we'll do it together. Okay, we're back. Inequality, so that is the answer. So if you got that right, good. So that was the class today. If you'd like to take screenshots of this practice test that we just completed, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3, number 4, number 5, 6, 7, 8, and 9, but don't go before you get your practice test for homework. Remember, the homework is another practice test. I know these practice tests are difficult, they're a lot of work, but you cannot pass the exam in the next class unless you do them. So these are not optional. Here's screenshot number 1, screenshot number 2, and number 3, 4, 5, and 6, 7, 8, and 9. But don't go before you get the answers to the practice test. It's not enough just to attempt the practice test. You must do it completely and correctly. So here is screenshot number 1 of the answers to the practice test, version 2, for your homework. And here's the rest of the answers for your practice test for homework. So get that practice test done, and I'll look forward to seeing you in the next class when we take the final exam, part 1.